Well, hello there, and welcome back for a bit more game development. Last time we started looking at avatar roles. So essentially, roles that the player can have for the current vehicle or whatever contraption they are currently controlling and piloting. And so, for example, for the mother vehicle, one role would be the driver, which would allow the player to drive the vehicle around. Another role could be a crane operator, allowing the player to operate the cargo cranes at the back of the vehicle, and so on and so forth. And for this system, we need some kind of in-game menu. So something that kind of comes up here, or in the middle of the screen, whatever we come up with, which allows the player to switch between the different roles that are available for the vehicle they are controlling. And last time we started working on the data part of this. So if we go into the blueprints, we have the mother vehicle here. And if we go down to the avatar component here, vehicle avatar component, we added this array of roles. So this now has two roles available. We have the driver and we have the cargo crane. And we have some positions that are sort of in local space of the current vehicle. You can sort of specify, okay, where is the camera supposed to be sort of orienting around and all of that. So pretty good. And we were able to actually print them to the console. I was actually able to, I had some problems last time getting my normal debug console to work, but I did get it working. So if we go here to game object components, vehicle avatar component, I have this small piece of code here that just iterates over the roles in the blueprint properties and just prints the roles, right? So now if we build this and we run it from here in the launch JSON, there's this thing called the new external window, which I didn't know actually. It says here that non-console applications will run without a window. STD out, STD will be ignored. Well, that's actually kind of what I want, because I already redirect them properly here to this basis debug output. So now we have our roles here. That's really great. And we can see that the base truck 2, so that's essentially this guy, this base truck 2, as well as test vehicle 1, which is this guy, test vehicle 1. They both have only the driver role, while the mother has the driver and the cargo crane. So this now means that we can essentially just use this list as the entries in the menu, right? And so I think we have all the data we need now. Sort of, we have immediate need for to get working on this menu thingy. So how do we create a menu? So one of the systems I have here as part of the basis engine is the Goofy UI system. I created a video about Goofy if you want to sort of see what it looks like and how it works. And Goofy is a C++ project. We go here to the C++ side. We have Goofy here, and there's a few. It's not super large, but there are a few classes and types here. Some widgets that you can create. It's sort of like a I create what I need whenever I need it thingy. So I don't have like a whole lot of features yet, but it's quite capable. But as you may or may not know, I'm in the process of moving things from C++ over to SIG. So Goofy will still be a C++ library, but we have started exposing, or I have started exposing things to SIG with the intent of building as much as possible in means with SIG. And so I think we're going to have to actually expose a little bit more today to get started on this menu thingy. So let's do just that. But how do you actually create anything in Goofy? Well, Basis currently has, and has actually for a long time, used AngelScript as its scripting language. AngelScript is actually pretty nice to use, in my opinion. The problem with AngelScript is that it's pretty tightly, not really tied, but it's like it's definitely designed to be used from C++. And since we're in a way moving away from C++ as the sort of end user, if you consider the game developer to be the end user of the engine, the end user language is more and more becoming Zig, then AngelScript is not really a good candidate for that. However, in the meantime, until we have everything moved over, we will still continue to use AngelScript. And if we go to game means data, and then workflow root into the game, resource pack, UI and scripts. We have these scripts here. You can see that these all represent a view. And here we have, for example, outpost view. This is just straight up copied from slide when I created the main means project. So we don't actually really need that, and I don't think we load it, but we have it there. And I should probably make these so that they update with Sublime Text or some better text editor than Notepad anyway. Okay, so I actually had the pause menu here already, but you see the main menu view here. If we run the game, once again, start it up there. And oh, yeah, I have it set so that it goes into the game directly, so we just need to back out into the main menu. And we have our beautiful temp development main menu here. Like these buttons are sort of intentionally hideous. They're skinnable, so the idea is that I shouldn't want to look at this for very long, and instead just skin them. But of course, I'm so lazy that I haven't done that yet. But anyway, you can see here that the view here that we create corresponds very closely to this thing here. Like if we comment out the exit button, for example, it just goes away, and so you can see that we have script hot loading as well, and yeah, I think we will use AngelScript, even though we can't really realistically bind any AngelScript to Zig. We won't really need to do that for this menu to work, because it will go through the C++ runtime anyway. But sooner or later I'm gonna probably want to actually not to get rid of AngelScript, because it's still very useful to have, and it works really well with C++. But I am planning to replace at least most of it with my own node-based scripting later on, and I think the Goofy system will probably use that kind of node-based script as well for this kind of stuff. But yeah, so this is main menu, and if we go back into scripts, we also have HUD view. Let's open this, and we can see that we actually have a lot of just stuff here, even though means doesn't really have a HUD or heads-up display. Like we don't really have anything. We have some some debug text here. We can just clear everything essentially. And now it's just an empty screen. And that's because even though we're creating these objects here, these canvases as they're called, we're not really doing anything with them from the code. Here we have a work in progress label that we can uncomment and it should appear. Ta-da! Work in progress. If we make the screen a reasonable aspect ratio, it should be in the correct place. So yeah, basically what we can do here is we can create a bunch of different widgets. I don't really have any like auto completion here. I mean, Sublime gives me something, but that's just because it has actually seen all of these words here in this script. So that's one thing that I'm not super happy with currently. I mean, it's not really AngelScript's fault. It really doesn't know what to do with these things. It doesn't have any language server running or anything like that. But there are a few things that you can create that Goofy supports right out of the box. Yeah, you can just create new UI elements like this on a view. You don't really have to like do anything with them from code if you don't want to. Like a label, for example, is no, falling off the screen here. A label is pretty well defined even without any kind of code running in the background, because it's just a text. Let's see if I can I get back up to the world. I don't think I can find my way back anymore. Let's just quit and reload the level, I guess. Yeah. But then we have these things called canvases. and these are sort of like, well, as the name suggests, there are canvases. They have a name, they have a position, and they have a size, and that's essentially it. So then what you can do is you can get a pointer to the widget. All of these things are like labels, buttons, canvases, they're all widgets. You can get a pointer to the canvas with a certain name, and you can register a drawing function for it, for example, and then you can do essentially like anything. And so I think that is probably what we will do here, right? Maybe we'll create some nice widget type for this menu of ours later on, but for now it would, like, the starting thing to do would be just to have it so that we can draw like a thing with some text on it, and it should appear when we hold down some button, and it should get the texts from the current vehicle, right? That's a pretty reasonable first step. And we should make it so that you can do all of that from Zig. So how about that? Let's do that. And we can see here that if we go to slide, right? Actually, we can, yeah, let's go to slide. Let's put a new window and go to slide and go have a look at the UI stuff in there. So we have game, and we have UI, and we have scripts. So here we have HUD view, and well, it's almost exactly the same as HUD view here. We have some interesting things here, like we have an objective marker, for example. This thing binds certain things to certain properties. So we have first of all a HUD objective marker. If we go into the C++ code, because slide is written almost completely in C++, there's no SIG really to speak of. There's a little bit of SIG because I was prototyping SIG using slide, but there's no Zig to speak of really. How do we actually get this? Let's see. Interestingly, it seems that these are actually commented out. Okay, so we probably actually don't really even need to do this anymore from the code side. What we can search for then is this objective marker visible thingy. Right, so it's a string. It's called in-game / objective marker visible, and you can register these things called properties, which we do here. Goofy Manager. So we give it a name and we give it a value. In this case, it's a Boolean. And then later on in the code, you can just set this to true or false, or give it some value, obviously according to the data type. And since this is a Boolean, you can bind the visibility to it. So that means that we don't have to show and hide this like explicitly. We just set the property to some value, and this bind visibility to property just specifies that yes, it will actually get its value from that, right? And you can also bind the position to property, and there are certain things that you can bind to properties. Not that many currently. Again, implementing things as I need them. And so to show the objective marker in the correct place, we actually don't even need this name. We could probably just take the name away if we wanted to, but it's there. It doesn't hurt, and the only thing you need to do to get the thing on the screen is to set this to true and then set this to some value. So we should probably do the same thing for this role selection menu in means. And that means that we have to somehow be able to register properties and set their value in Zig, which we can't currently do. So that's kind of a problem. I do actually wonder though, because this is a canvas, right? I think we actually need to still get a... I think we still need to get a... Alright, but I was in the wrong project earlier. Yeah, that makes sense. We still need to get a handle to it, or pointer to it, and with that pointer, or actually I have like a class here that wraps the whole thing. We then need to draw it from code, because it's a canvas. And that's what canvases are for. So here at some point we have a render function. Here we go. And this uses NVG, NanoVG, which is the third-party library I'm using for rendering the Goofy graphics. And then you can just render things with it. Yes. Okay. So we need to do something like this. Expose this kind of thing to Zig, and this is the important part. Like we get the HUD view, we get a widget from the HUD view. This is the get widget we looked at earlier. Or maybe we didn't look at it. I don't know. I can't remember. We get a canvas. Then we set a render callback. For that widget, or that canvas in this case, and that render function is this one that we just looked at. And yeah, I think that's all we need to do to get the menu onto the screen. Right, so what's the first step then? Well, we already have the HUD view in Zig, or rather we have the UI view, right? Let's go to Goofy. We have UI view. Here we go. So UI view pointer. As a small side note, because I don't think I've mentioned it during this video series, I have this PTR pointer. There's a naming convention that I use when I have something that really just wraps a C++ object, so that you know that this is really a pointer to something. So a UI view pointer really only contains a CPP pointer member, which is a basis int pointer, and anything that you call on this typically just uses this C++ pointer to figure out, like if we want to get the canvas with a certain name, for example, then it typically goes via the C++ side and gets that. And that, of course, is so that we can have SIG and C++ interact with, like, using the same data. Ideally, if we were sort of completely free from C++ at this point, which we aren't, but if we were writing this completely in SIG, then obviously we wouldn't have this. UI view would just be a struct on the SIG side. But it's not. It's really just a pointer to something that lives on the C++ side. And the way we get one of these guys is by calling create view. We give it a name. We get back a UI view pointer. And you can see here that we initialize it from a CPP pointer, which we get through the binding system when we call create view, etc., etc. So, right. The first thing that we'll want to add is this, probably. So, hot view get widget, and we give it the type UI canvas, and we pass in the name. All right. So we should really try to replicate that on the C++ side. I'm going to drag this off to the second monitor for a second, and we'll have a look at the bindings. So we have Goofy. I don't think I've actually talked a lot about bind a lot. I mentioned it in previous videos and video series. So this is my completely homemade binding generator system for Basis and Zig. It can technically be used for other languages as well. I have a proof of concept Rust generator for this as well. But I don't really know Rust, so it really remained at the proof of concept stage. It did work though. Probably doesn't anymore because I haven't maintained it. But anyway, so what we have here is almost kind of what we want already. So write this sort of weird pseudo C++ or C or whatever we want. So we have a class with a name and I wonder, should that be called Goofy UI view pointer? Probably shouldn't. Let's see how does the bindings look for the actual. So it's called client, but still we have client pointer here, right? Yes. Yeah. Again, I haven't done a lot of SIG lately, so I'm little rusty. And yeah, it gives me a bunch of errors. That's just because I have the syntax. There's a bind a lot file. I have a syntax highlighting for this file set to C++. So it's like, what is this? I don't understand. You don't need to worry about any of the errors. Actually, they just stop after a while. I think it reaches some like a few hundred errors and then it just gives up. But yes, so you wrap something that you want to expose to SIG in this class. It doesn't technically need to be a class, but it can be a class on the C++ side. In this case, it is. It's a UI view, right? So, what is it called on the UI on the C++ side? It's called the UI view. It lives in the Goofy namespace, so it can be called Goofy UI view. That's fine. And right, so what we want here is we want to get a widget. We want to get a widget from this. So the C++ side has something that looks a little like this. Right, it returns a pointer to a widget, and it takes a name. And then there's the, I can just show this to you here. So it's this guy here. You can also do it with the name hash if you want to. And then there's this templated version that just casts it to the correct type. Maybe we'll do something similar on the Zig side as well. So how do we actually do this now on Zig? Well, Zig doesn't really understand C++, but it does understand just raw pointers. So we can do uint pointer t, and we call it get widget again. And in C++, you have this hidden this pointer, which we don't have in Zig. So we just call this. What do I actually? I think I had a. Yeah, this is the convention that I use. This pointer, right? Uint pointer t, this pointer, and we need to give it a name, and I have this interop string type which I use for this. So this would be name, and now using this we can get a pointer to a class that Zig really doesn't understand, because it doesn't understand C++. It does understand C, doesn't understand C++, and the whole binding of C++. I think we can get rid of that. We don't need that. This Zig import path thingy here is something that bind a lot needs. I'm not going to go super into detail now. It has to do with how it generates the bindings. Anyway, so what we get here is we give it a pointer to something, this pointer, which Zig really doesn't understand. It just knows that, oh, okay, this is the Goofy UI view. We give it a name in interop string form, and it gets us back another something which we don't understand, but which we know is the, okay, this is the pointer that represents the widget on the C++ side. And we don't really need to know anything about that pointer. We know it's 64-bit because it's a 64-bit application, but we don't know anything else. We just hold on to it and go like, okay, this is the widget. And when we want to ask something about the widget, like, you know, is visible or something like that, we just call some function that we have exposed as well, and we pass that in and go like, here is the pointer that you gave us to this thing which you said exists on the C++ side. Tell us if this is visible or not. Right. So now that we have this, we can run this batch file. So let's open this in File Explorer. We can run this, and it says 0 warnings, 0 errors. That's good. And yeah, we go here to this, and this is where things start to kind of fall apart a little bit, because bind-a-lot is really only kind of properly working for binding basis things as well, but I've sort of forced it to work for other libraries such as Goofy as well. But the problem is that this is what we actually need. We need to import basis, and then we also need to import Goofy. And bind-a-lot currently just overwrites those things. So we just need to revert some of this. Like, nope, revert that. But it was good the way it was. And here I wonder Is this now the correct thing? That's confusing. Oh, you know what? You know what has happened? I think I know what has happened. Yeah. Yeah, so look at this when I go and see what, are you seeing what's happening? Like the Visual Studio Code is auto-correcting it believes it's being smart. So when I save this, it jumps one slot to the right, which Bindelot probably doesn't understand anymore. That is so stupid. That is so stupid. Let's open this up with something else. I don't like this. I don't like this editors all of a sudden. Let's open it up with this one. Right, and basically what we need is this. Like, yeah, my parser for this thing. The Bindelot parser should really handle this, but it currently doesn't. Oh well. Yeah, so it doesn't realize that these things are actually pointers, because it expects the asterisk to be right next to the type name there. Oh well. I should make a to-do note for myself to fix that, so that the parser doesn't trip up on that thing. But now if we regenerate these things again, right, now we end up with something that looks much better. Again, we have these things that Bindelot just currently doesn't handle correctly, and so we need to yeah, we can just save that. Same thing for this, I bet. So we really didn't change any of these other things. We don't want it to change them. We just added a new one. Generated type is kind of fine, but yeah, there's some work still to be done on the Bindelot side. Okay, but yeah, here you can see that what it does. It generates some types for us. And so these are function pointers in Zig, and it separates these classes out. We have Goofy Manager, which really isn't a class on Zig side. Well, nothing is, but it's not even a struct on Zig side. It's just a module, but it's still like represented by a class here in the Bindelot code. And all the functions that we expose from C++ to Zig have this function pointer, a callback, really. That's why it's called CB. And this is the way that we get it to be type safe, because we only use these names on these aliases, if you will, when we are actually referring to these. And Bindelot is the one that generates all of these things for us. So, provided we don't do anything silly like we just did, it should just generate everything for us correctly. And here we have to go in and actually change Goofy. Can I edit something here? Yes, I can. Okay, cool. So let's just make that Goofy. Save. And I have been using Perforce lately a lot, so I keep using Perforce keystroke, like shortcuts. They don't work in SmartGit. Okay, cool. Yes. So now that we have this Goofy UI view class here, if you will, it's really quite easy to expose other things. Now we have this getWidget function exposed, but we can really easily expose other things when we have this sort of infrastructure for it set up correctly. So that's correct, and that's also correct. Okay, and the other things that it did is that it generated the C side for us. So this is essentially the exactly same thing. Here we have Goofy Manager, we have all of its things, and then we have Goofy UI View, and we have its things, and it also generates, among other things, function pointers or type defs for function pointers. So here you have uint pointer t. We have the name. We have this pointer, and we have the name, which we set up there in the bundle file. Right. Okay. So now we can go to C++, and we can go to Goofy Zig interop, and we can have a look here. So we're exposing the Goofy Manager through all of these C functions. Again, Zig only understands C, so we have to go through C, and that's why this whole section is wrapped in extern C, to make sure we don't do anything funky, any funky name manglings or anything like that. And now the interesting part here, at least I kind of feel like it's pretty interesting, is that we can just take this guy exactly as it is written here in the bind.lot file and just copy it in here, and this will be the actual function that will be run when we call this from Zig. I just prefix it with the name like that. Okay. And we have some old things here that we don't need. But take that away. Right, and then we need to hook up the function. So one thing that we generated for us as part of this whole bind.lot thing is export function bind Goofy UI View. So this will now be available from our Zig library. And Goofy UI View, is that actually, yep, I think that's exactly how it was called. And bind Goofy UI View, you can see it already knows that it wants the get widget callback. So we just expose it like that, and essentially now we have it exposed from C++. Now it doesn't do anything here currently, it just returns 0, which is equal to a null pointer. So let's actually implement the thing, right? So we have Goofy, we have UI View. So there's a little bit of work to like hand wrap these things. And so what we can do here now is it's in the Goofy, yeah, it's in the Goofy namespace. So we have view, and we can do a reinterpret cast into a Goofy UI View pointer from this pointer, like this, and not this, but this pointer. Right. Well, I don't do that in this file. I think that's how I did it. Other files, let's do basis Zig interop. This is a huge file which just exposes like the bulk of the basis things. Here I'm actually calling it CPP pointer. So it looks like my naming convention wasn't that rigid, but yes, you do a reinterpret cast into the pointer that you want, and then you call the actual thing on it. Good. And what about the interop string? Yeah, I just do it like this. Cool. Okay, so we have the view there, we have the name, and we can call this like widget name or something. So interop string is really like the equivalent of slice in Zig. It's a pointer and a length. Very simple stuff. but Goofy wanted it as a string, so we can just create a string out of it. Okay, and then we get the widget. So Goofy widget, get widget with name. And now, of course, this might return null if it doesn't find a widget with that name. Yes, it just looks through a list and returns a null pointer if it doesn't find it. But oh, we should use widget name here. But that's fine. We don't really need to worry about that. I think we need to reinterpret cast it back into a uint pointer. Yes, that is exactly what we want. So let's do widget. Right. So that should be it. That should be everything we need, really. On the C++ side, to be able to get a widget, we can't really do anything with the widget yet, but we can get it. We can figure out if it exists or not. So SIG tells us that, okay, I have this pointer here which I don't know anything about. I only know that it belongs to a UI view, and I have this name. So please get me the widget with that name. And then here we go, like, okay, so this must be a UI view pointer. We reinterpret cast it into that. We do convert the widget, we get the widget, and then we just reinterpret cast it back, so the actual widget pointer this time around, into a UI pointer view. And that's it, really. So now then, let's build this, and we are building in debug, it would seem. That's probably fine. And on the SIG side, we also have to do some work. This seems like an awful lot of work to expose the type, but like I said, once we have the type actually sort of done for this one method that we want to get a widget, and we want to actually we want to get a canvas, which is a widget, right? So I wonder if we actually want to like have any kind of widget type here on SIG. We might actually just want a canvas type directly. But anyway, once we have this set up for just this very most basic of uses of a widget, then it's really easy to add more or expose more members of that type, which is really quite nice. So maybe we'll add a folder here. And do we just, I don't know, maybe I'll just add a new file here directly. So we'll call this canvas.sig. And I better have a look at how this looked. Yeah, so we want all of these probably, and then we want pubconst UI. Oh, it's not that. It's canvas pointer. Because again, remember, this is just a pointer to something on the C++ side. And we want to make it very clear to the user that is the case. It has a CPP pointer. This is the same uint pointer, but it's called basis.int pointer. This is really just like it's a u size, but this kind of suggests that it's actually used to calculate the size of something. I have this alias here to make it very clear that we're using this as a pointer on the C++ side. Yeah, we can just copy all of this, whoop, like so, and we return a canvas pointer. Let me just do that. Yes. Wouldn't that work? I don't know. Maybe it doesn't. Oh, So now we have a canvas pointer. We can now represent this with something on the zig side, and we should probably actually Goofy UI pointer. I'm just a little confused here. Oh, there we go. Yeah, okay, we're sort of forward declaring it like this, but that's probably fine. We can do canvas with a small c, and we import canvas.sig like this, right? And then here we just do canvas pointer is canvas pointer. All of my IDs work slightly differently, so I just make these silly mistakes. Okay, cool. So now we can do like Goofy, which is this file dot canvas pointer, and that will point to the thing. Okay, good. And now from the UI view, we need to be able to actually use this, right? We need to be able to get the canvas out of this. And on the C++ side, we use the template, so maybe we'll do something similar here as well. So that we can use the same function to get different types of widgets. I mean, it's called get widget after all, not get canvas. And how did that stuff work? So Goofy bindings FB, and then that, right? So we should be able to, like, if we have a pub function get widget, and we have a comp time t type, so we give the type of it, and then we have the name, which is a string, which looks like that. Then we should get an optional t, right? If it's null, then we return null. Yeah, unused something or other. And interrupt name. I think this is basis string to interrupt string, and we give the name there like that. And it probably just tells us that it's unused again. Yes. Yes, it does. And then we do Goofy. Bindings, function pointer, and don't we have the thing? Don't we have the thing? Why don't we have the thing? Generator function pointers. We do have the thing. The IntelliSense just hasn't caught up with us for some reason. Like that. And this now took this pointer. So this would be just self. All right, we need a self pointer here, right? We need a self pointer. I keep forgetting about the self pointer. So self.cpp pointer, and we need the address of the interrupt name. And this gives us something, right? So this would be widget cpp pointer, and then we can return t dot, and what did we call it? Init from cpp pointer, widget cpp pointer, something like that. And I just love how easy it is to do comp time things. Like this is essentially the equivalent a template in Zig. The equivalent of a C++ template, but in Zig, and it's just so much easier to use them from Zig than it is from C++. Right, that succeeded. Doesn't really necessarily mean anything yet. We might still get a compile error when we actually start using this, much like some C++ compilers do with templates. But yes, that's neither here nor there. That should be everything we need to do to oh, actually no, it's not. It's not. If widget CPP pointer is 0, then we should return null, right? Otherwise we return that because it's an optional T that we get out of it, which means that we'll have to check whether or not it has a value before we use it. Yes, that's better. Okay. So now then, now we should probably expose something, right, from the actual widget. Let's have a look. What would that be? Let's go to here, and we can have a look here with canvas. So this is the canvas data. This is the thing that you actually fill in here in these scripts, with name, with pos, with size, for example, with name, with pos, with size. You can also do the binding here, etc., etc. Then we have the actual thingy. So the slightly tricky one will be this render callback. We'll need to figure that out to actually be able to call something. But that's yeah, we need to figure that out. However, we have this, like, everything is a widget, right? So what we could do, just to make sure that our binding system, like, overall works, is that we could maybe expose, like, the label that we already had, right? Like if we go into the game now. Well, I don't need to even do anything. We have this work in progress here, which, if you remember from before, we actually we added to the script, and we can just, we can do really anything with it. We can go, hello, subscribe please, and it should update, which it does, and just make sure that our bindings work. We can just do something a little fun with this, maybe. And how do we do that then? Well, we get the label. We give this a name first of all. We can just call this test label. You don't need to give things names if you don't plan to actually refer to them somehow. I haven't really referred to this before, but now we need to do that. So we call it test label. And what we do now is we'll create yet another class, or not class, but struct here. And we call this label. Whoop. What happened? What did I do? I did something bad. Call this label.zig, and we copy essentially everything here from this. We call this label. Oh, label. Come on. Label pointer. And we also probably need to do this. We need to do pub label import label, and we need to do this. Or we don't need to do it, but it's nice if we do it, because then we can just type goofy dot and it will give us everything that it has to offer. Right, okay. Right, this guy will work just as well with labels as it will with canvases. We don't need to do anything here. But let's maybe... what can we do with the widget? Let's see. Yeah, okay. Right, we can set position. Yeah, maybe that is what we will do. Set position, maybe set visible is visible, something like that. Yeah. Yeah, like setting a position directly like this is perhaps not something that you're really encouraged to do in Goofy, but you can do it. So we can use it as a testing thing. Rather than setting positions directly, you would typically bound them to something like a property, and then set that property, and then that allows you to do more interesting things. But nevertheless, you can override it like this. So set position, and this will be self, and a position is a vector 2, right? Yes, it's a vector 2. So we can just do pos basis math vector 2, and that's a void. Right. Yeah, we can't do anything more than that. Let's just save it and let it add those things there. But that is essentially what we want to do. And now we can perhaps just start using it. I mean, it won't do anything yet, but we can see how we would actually use this. So in-game UI view model, and this guy is activated, and it pushes the HUD view onto the screen, and then it pushes the pause view and the game over menu view. And so GHUD view, this is the view that we are interested in here. So let's add G test label, and this is a Goofy label pointer, and set to undefined. Or maybe we can actually we can make it an optional, right? And have it be null instead. Right. I think so. And then here we can do gtest label. What? Label. There we go. Test label is GHUD view get widget, and the widget is of type Goofy label pointer, and the name is test label. Am I right, or am I right? Test label, yes. And then maybe we can just assert, we can do basis assert that G test label is not null, right? That's a good thing to do. This is all just testing code. We're not gonna keep the stuff we put in here in the UI view model. Okay. This should already work. It should actually assert now if it can't find it. That would be actually kind of interesting to see if it works. I think we're gonna build this in release mode. This will take a while probably. Haven't built in a little while. We can let it do that, and in the meantime we can build this, and it doesn't work. Expected blah 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 label pointer, blah 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 label pointer. What? pointer found canvas pointer. Oh, yeah, I gave it a canvas pointer, so of course it would tell me to get my stuff together. Okay, that succeeded and that succeeded. Okay. Right, so now we do like just add a 2 here to like intentionally break it. If we run this, it should go like ah. It failed. Breakpoint is there. If we this is kind of breakpoints in release aren't all that useful, but yeah, here we can see that it failed on that line that we just put there. And now if we take that number 2 out, it should work. Ta-da! Excellent. Okay. So that stuff works. So now then, we can do update, delta time, and let's just have like, okay, if G test label, right? It's an optional, so we need to do this. And that's like test label is the type that we actually capture out of that. So test label, set position. What do we do? It's like somehow. Yeah, let's just do something really simple here. So like G test label pos. This would be basis math vec2, and it would be at let's just get the initial position here. So that is the position right there. And it's probably called like init or something. Yes, it is. Right, and no F's here. No F's. Right, so if like every update, it would just take the Y and add the delta time to it, right? So something like that. And probably times something really small. Otherwise it just runs across the screen. And then we can just set this position like so. So it should start at the position it is at, which is at the top of the screen, and then it should slowly move down, right? If this works, that is what should happen. And what do we have? Set position. Oh, yeah. We're modifying it, so that needs to be a mutable capture there. And release building is a bit slow, but yes, it succeeded. Okay, now this won't work for pretty obvious reasons, right? Nothing happens. Why doesn't it happen? Well, because this thing doesn't do anything. So now, how do we actually get it to call into the C++ side? Well, we turn our attention to bind-a-lot. So we do class goofy label like so, and this is a void function, so no return value. Set position, come on, like so. We need this pointer again, and we need interrupt vec2 this time. Right, that is the thing that we want. And we generate this again. And now we can go here, back to the goofy zig interrupt. and we basically just copy this guy and we call this, oh, what do we call it? Goofy label. And Goofy label has one method function technically, but calls into a method, and we do something like this, and we have label. Is it called UI label? I think it is, yes. UI label. So label. And we need to include it here. Goofy widgets UI label. Like so. Right. We can just take that away. And right. How did the interrupt vector2 things work now? Was it just like from interrupt, right? From interrupt position, and that I think that should work, but it is possible that we need some kind of basis zig interrupt helpers. Yeah, that this is essentially what we want, but don't we actually have like who includes this guy? Is it available outside of basis? Yeah, apparently not, because I've had the same problem in timbre, which is also not in basis. Okay. All right. Well, let's just make life easy for us. Maybe we're actually making our life difficult for us later, but let's just do something like this to get on with our lives. I have a helpers there already. Right, so from interrupt, we'll get the vector2, which the label expects. Label set position, and it would be just that. Like obviously, I could add a method to vec2, which would allow it to be initialized from one of these guys. But I don't want to spread the zig on interruptings throughout the entire engine if I don't have to. So this is just a force inline function that converts it. Should be quite nice. And I guess it could technically even be here. Maybe, I don't know. Okay, so that's that. Then we need to hook up the new type. So base bind goofy label, like so, and then we call bind goofy label and goofy label set position. And if we have more, we just add them to this guy, like so. So provided this now builds, which it did, excellent. The only thing we need to do now is go into, not here, but here. And we can do basis, no, not basis, goofy, bindings, FP. We always like one thing behind. So now we have the goofy UI view, but we don't have the goofy label. Come on. The intelligence being very, very kind once again. It's not that, it's this guy. Set position. Set position takes self.cpp pointer, and it takes, right, we need to convert that. So let's do const interrupt pos is pos dot to interrupt. And what we want is the address of it. Okay. Does that build? So there's like a whole lot of work up front when you're exposing new things. But now, if we wanted to do get position, for example, it would be actually really simple to do. Let me just actually show you how easy it is. So we go in here and we yeah, we do get position. I think I typically do these with like a writable pointer, something like that, right? Okay, so we generate that. And now we go into the C++ side. And we do basically this. We do a get. We do, that's not a const anymore. And we can do we can do vec2 label pos is label get position. What, really? Oh. What? You can't get the position. Well, yeah, you can get the bounce. You can't get the position. Oh, that's stupid. Well, yeah, you get the idea. It would have been very easy if we could get the position. We basically just need, the thing we need to do is we need to add it. It even gives us an error. It's slightly difficult to see, but since everything is type safe and everything, you can't really forget to add these things here. You need to do it. Let me just see. Can I hack this somehow? Like, goes in the UI widget. Hello, yes, go in there, please. Position. Yeah. I think we should be able to get it out of there if we really want to. We have a reactive. And reactive is the thing that really is the thing that you can sort of you can bind these properties to. Yeah, so you can use get to get it out of there, right? Okay. Okay, let's just actually add it here. So that would be a const vec2 reference get position const and be return position get. No, not like that. Like that. Get returns a const reference. Like so, and a timbre. Goofy is there. So we can make that a ref then. And then we just, I don't think I have a helper for this, so I'll just write them by hand like this. Hardly the most elegant code, but whatever. So okay, that's what? So many errors. So many errors. We need to put a basis there in front of that. Don't you like it when if we get one word and you get like 200 errors? So very nice. Yeah, okay. Right, so that was everything we now needed to do on the C++ side. Just create this thing, add it to that list. And now on the SIG side, we can just do pub fn get position And writing position seems to be the most difficult thing to do ever. Basis math vec2. Right. So we need a var interrupt pos, and that's an interrupt vec2, right? Right. Basis bindings interrupt vec2. That is what it is called, and it's undefined. And then we do goofy bindings fb. I said goofy label get position and self cpp pointer interrupt pos, like so. Then we do return basis math vec2 from interrupt pos. Boom. There we go. And that should be it. So now, now that we have a type already exposed, you can really easily and quickly add new, like expose more methods from a C++ type that you've already exposed some of by basically adding this row here, adding a method on Zig side to like zigify it a little bit, and like return a nice basis math vec2 here, for example. And then write the actual function on the C++ side, and everything else is sort of handled for you, which is pretty cool. Okay, so that now succeeded. So with a little bit of luck, now if we run this, it should move the text downwards, and it doesn't. So why does it not do that? Well, there can be many different reasons for that, but let's see. I think what we should do now is we should build this in debug mode, and we should build this in debug mode, and then we should make sure that this thing actually executes. Right, so that succeeded, despite it looking like it kind of gave me a bunch of errors, but they're merely warnings. So do debug. And we can see that, okay, it actually does run, and it sets the thing. And what is pos? Well, it's a little more, right? Okay, get into position. And we do get here, okay. So that's interesting. Why is it not moving then? Yeah, it is actually running that. Yeah, it's not moving. Could it be that we made it so very slow that we quite simply cannot see it? I guess that's always a possibility. Yeah, doesn't quite seem to be the case though. Let's see. What do we have? What do we have? Right, so unbound, and we get the value. And the value is already quite large. And still it doesn't. Oh, Is there actually like a... It does calculate the bounds, right? Yeah. Let me just figure this out quickly. Okay, I think I've figured it out already. So if you go have a look here at button, for example, we have this line here, which gets the pixel position from the UI position. The UI position is like normalized coordinates. So in case of the Y coordinate, like 0 is up here and 1 is down here. Get pixel position from that. So this should be fine. The label, for some reason, doesn't do that. It uses data pos. So this is the initial position. It always uses that. I think it should use position instead. Font size probably doesn't change. Color doesn't change. Presumably the text doesn't change, but maybe that will change at some point. It will change that it can change, and then we should be good. But anyway, I think this should probably fix it, and I also think that it should be quite slow. And yeah, okay, so now it moves. It just moves very, very slowly. So maybe not quite that slow, right? Make it 10 times faster. And we can see what's going on. All right, there we go. So now it works. Now we can hook into these widgets from Zig, and we can adjust their properties. Well, we can adjust the position of a label. But this is the beginning of being able to properly render the canvases from Zig, which is what we will need to do the menu. So yes, I think I'm gonna end this video here. This was a lot of work for seemingly little benefit, but we are on the right path to being able to set up that menu, which of course in the long run is only one step on our way to being able to lift things and other cars with the crane, which is why we actually have these roles in the first place, so that we can control different parts of a vehicle. And I think this is the correct way to do this. It's nice and data driven, and should have no problem adapting this system for all kinds of gameplay features that we'll want to use in the future. Okay, I'm gonna end this now. Hope to see you in the next one.